To understand the concepts that are involved in the frequency of the string, and to show the influence that the length of the string and the tension applied to the string have on the frequency of the wave caused by the oscillation of a string.
So how we're going to do it? Well, we're going to make a system that will involve a wooden board, a guitar string, and a bucket. We are going to measure the whole string in order to get the linear density. This will be our first length. When we cut both notes, well, we have a second length that will go inside the formula. It will be length 2. We'll call it that way. Here, inside of the bucket, we will have to add a certain mass that will be in liters, and of course we will have mass times gravity. This way we will have the tension, and right here we are going to add a support so the wooden board won't move and the tension will be inalterable. And well, that's how we're going to do it.
It's 3.375 grams.
First, we have to estimate the linear density, will be our mu. Mu is defined as the mass of the string over the length of the string. The length of the string will be our length 1 that we have established previously, that is the total length of the whole string. Our mass we have already estimated that it was 0.0037 kilograms over our length 1. It is going to be about 0.744 meters. This will give us 4.973 times 10 to the third minus 3 kilograms over meter. Now we have to establish the formula to calculate the frequency. Will be frequency equals 1 over 2 times the second length, that will be the length for the two cuts of both notes of the string, that will create the tension, times the square root of the tension over the linear density. We have already established that this length will be about 0.223 meters. So we already know the frequency that we want to obtain, so it will be 440 Hz equals 1 over 2 times 0.003 times the tension that we want to get, and the linear density that we want, 497 times 10 to the minus 3 power, and the tension will be, we have a tension of 139 newtons. This is the tension that the string has to have in order to get to this frequency. It will be about 18.76 liters of water that we have to add to the bucket in order to get to the desired tension, in order to get the 440 Hz.
A bucket with 19 liters, so we have to get a little of that 19 liters out of the bucket with this 40 milliliters cup.
Okay, now we have our bucket with 24 liters, and we're going to measure the frequency of our oscillating rod. It should be more or less at 440 Hertz. We are going to, Lube has his frequenzometer to measure. So here we go!
Más.
In the second part of the experiment, we need to calculate the length with the frequency of 392 Hz. And since we have already calculated the tension in the first part of the experiment, which was 191.39 newtons, and we need to use the same linear density calculated in the experiment number 1. And we got that the length is equal to 0.25 meters.
And we obtained that with a length of 0.25 meters.
There you are, 25 centimeters.
We are going to obtain a frequency of 392 hertz.
More or less.
More or less.
By changing the length of a string, you can alter the wavelength and the frequency of the wave produced by the oscillation of your string.
The frequency at which the string vibrates depends upon the tension of the string, the linear density of the string, and the length of the string.
If the string is larger, then the frequency at which the string vibrates will reduce.
The higher the tension, the higher the frequency.
Here.